All right, talking at the back of my head, that's what you get. Checking that the markers work, none of them worked. We're going to try and get back on the streaming horse, and so the first thing we're going to do is we're going to do solutions to the homework that I still haven't posted because we made new assignments, but no good deeds goes unpunished, so I don't have the solutions ready. Let me pull this up. The first, well, we'll see how far we get because I've got a bunch of crap that I have to do also. So later today, 2x2 system should be really quick. And it seems like Lorenzo was making these, and you did one of each kind. So if number one has three kinds of solutions for 2x2 linear systems, a lot of them were still mystified as to what we mean by geometric interpretation, even even though I do this. And the number one thing was, can you tell the grader to put more comments? Because I'd like comments on what I did. And I said, no. They've now started just straight up no. And I'll give a good reason. Yeah. If they go back to having classes of about 20 or 30, then I'll put comments. You give me 75 to 300 students in the class, no more comments. Yeah. I'm not doing that for 800 students that I have every semester just to please a few students because you'd like comments on what's wrong. It's your job as a student to actually, if you want to learn, especially for the good students that are genuinely not being whiners, but saying, I'd like to know why it was wrong. Now you can use the solution and match when I do it and then pay attention and either watch this later or go through the solution and find out why you're doing this. The other one that I was going to do with Tim was we're going to start a series where we start doing statements or mathematical statements and or book reviews of good math books and bad math books and trying to convert academese into plain English, and what does the mean value theorem actually say, and how do you as a student, especially as a first year student, start comprehending what the hell this statement is saying. I can read out the statement. Let f be continuous in a closed interval ab, let f be differentiable in an open interval ab, and let f of a equal f of b, or and then Rolle's theorem is going to say what? Then there exists a c inside the open interval ab such that the derivative is zero. What's that going to get for you? These types of things, and where do I use it, and how do I actually convert what the statement is saying, and all these types of things. So my other rant was the students, the number one thing that students say, or for some reason in K to 12 possibly, I'm guessing because I have them in the first year class that's where most of them are coming from. They start trying to do problems, and then they'll send me an email saying, "Can I have a bunch more problems because I'm not getting it?" And that's the analogy is if I want to get swole and I want to go lift a bunch of weights in the gym, they're like, oh, I can't lift this one up. Can I have a new set of weights or can I have a different kind of? No, you need to take a smaller kind and then use that same set of weights, just take a few off until you can lift it. But it's not changing the numbers that I'm about to randomly do. What Lorenzo was convincing me, I'm like, I didn't even look at these. It's like, it's linear algebra 1. I'm pretty sure you'll be okay. It's like, but the numbers are changed. It's like, no, but I know how to do row reduction, so it will be okay. So this is what they do. It's not the numbers that change and the number of different kinds of problems in that category. You need to learn what row reduction means, that we have three operations. You need to know and train yourself to see what row echelon form looks like, but you can use the same problems. The whole time I do the course, I use the same problems. And it's really good as you're doing this to guess and check, and when you have a new process to do the same thing, in linear algebra specifically, we eventually get Gaussian elimination, and then for a unique solution. And then I get inverse matrices for a unique solution. And then I get Kramer's rule for a new solution. But I'm not changing the system. I'm going to use the same system to show that I get the unique solution every time. So it's not changing the numbers necessarily. You need to, or the notation. It's the process that you need to start focusing on. Learning the process is a lot harder than just regurgitating an algorithm. Timmy, you need to go to grade 8, so we're going to pass you even though you're an idiot. So, rant over. 2x minus 3y equals -2. But yeah, it's like they keep asking for new types of problems, and it's like going to the gym and saying, I don't like these sets. Can I have a bunch of different sets of weights? It's like, it's not the weights. It's your technique is crap. 9. Oh, Loren, did you just use Chat GPT to auto generate numbers, or did you do it just blindly? Right. I laugh because mantra one is, well, augment the matrix. This is, what does he call it? A. Mark likes A. I like I for Roman numerals. Oh, let's put that slightly over here. Can you see it in the thing? No, you can't see Treebeard either. But after I augment the matrix, watch. Here's a little tip for you. Well, there's an entendre there. I'm allowed to do that because it's Twitch and it's not McEwen. Here's a tip for you. I see a 1 right here, and I want a 1 in this top left corner. So as I'm even changing it into the augmented matrix, I'm going to go 1, 1, 9, 2, -3, -2. See what I did there? I interchanged the rows as I put it in the augmented matrix. I'm just writing down what we're going to do next, so I guess I'll write it. Row 1 interchanges with row 2 as I go into the augmented matrix. Now that's the first mantra. I have, oh, hot pink. No, sadness. Are all these dead? Oh, orange. Okay, Halloween. I have a leading one you have to eliminate below. That's why it's called Gaussian elimination. After I do this, it will get rid of the 2, which is 2x. So I'm just going to kill the 2x in that equation. So this should be row 2 goes to row 2 minus 2 row 1. Also, if you don't like that, what you do to one side of the equation, you have to do the other. So I'm multiplying effectively by -2. So there's a nice trick for you. Then I'm multiplying the 2 into each spot. And what do we get from this? I'm going to get 1, 1, 9. And then I'm going to do 2 minus 2 is 0. -3 minus 2 is -5. I see why they hate you, Lorenzo. And then, oh, I really see, what is that? You're going to make me do 2 times 9, -18, -20. Okay, that's not so bad. Mark is so clever. And then what are we going to have? I'm going to now divide to get, this is REF. Because REF, Mark says, as long as you have the staircase, I don't have any rows of zeros, so they would go at the bottom. I have 2 leading entries, I have zeros below them, and I have the staircase, which means in any 2 non-zero rows, the leading entry in the upper row is further to the left than the leading entry in the lower row. Staircase, I say, fake it till you make it. But once I have this now, I could go 1 more, just because I see that it will start reading it off. And if you want, for the first one, this is a unique solution. Also, at this stage, I can tell there's a unique solution because I say, what's the real condition? If you have the same number of leading entries as you had unknown variables, you have a unique solution. So I know that it's a unique solution, but because it said solve, you can't just say that. I have to keep going further. But 5 divides 20, so I could keep going. Another alternate REF is going to be 0, 1, 4. I divided this row. Row 2 goes to -1/5, the inverse, row 2, and that gives me this. But now you forget, as I train, you don't mind going from the matrix to the, or from the system to the augmented matrix. But now if I have to go to the matrix, all we were doing was making an equivalent, easier system to read off. If you want, I could go 1 more. This is also an REF. And then if you want me to do 1 more row operation to get it to our REF and backtrack. So for the first one, I'll do both scenarios. I guess for all of them, we'll do both scenarios. The camera's on, and it's been a while. Turns out I like talking. So turns out you put a camera on me and talk about math, and I won't shut up. And they're like, yeah, we know. We're aware. It's never got me in trouble ever, luckily. So this is REF. From this system, turn it back into the system. What that says is, and why I say, unless we're doing inverse of matrices, you never have to go to our REF. You can always get the solution, and the first row will never change because you're going to use the first row to manipulate the other rows. So this still says x plus y is 9. But this one, importantly, tells you why they called it elimination. It's eliminated x from this equation, and now that just says y equals 4, which is a 1-by-1 linear system. Even if I did it here, this one says -5y equals -20, which is a 1-by-1 linear system, and I could solve for it. So at any one of these stages, I can see that y is now 4. But that means that this is a 1-by-1 linear system because I can put that in there, and that says x plus 4 equals 9, and so that says x equals 5. 9 minus 4 is 5. I have to double check just a second. Yeah, it checks. So the unique solution is x equals 5, y equals 4. You can also check that. This is what we mean when we're doing the theory. Oh, I was going to go to RREF. That's okay. So now if I go to RREF, I'll remind me to check in a second. So, but this was 119014. If I want to go to RREF, this has to go away because I need leading or zeros above leading one. So we're going to go to now row 1 gets changed to row 1 minus row 2. And so when I do that, I'm multiplying this by -1 and then adding it. So what am I going to get? I'm going to get 0, 1, 4. It won't change. 1 minus 0 is 1. That can't change. That's why we're doing it correctly. Then 1 minus 1 is 0. That's why I did it. And then 9 minus 4 is 5. But what that does now is just read off the solution. That says x is 5 and y is 4. So in reduced row echelon form, it will just read off the unique solution. This is what Gauss and Wilhelm Jordan notice. So that was a lot. Whether I use this REF or the REF where I like it when they're leading ones because it makes it simpler. And then if you're going to go all the way to RREF, you already are, the restriction for RREF is that you have to have all leading entries are leading ones. And then you have to have zeros above and below. And then catfish, when we are trying to do this block form to find inverses, this is the identity I2. Really what you're doing for a unique solution is turning the coefficient matrix into the identity matrix. And then it will just read off what the solution is. But once I have the solution and you're on a 50-minute exam and you're worried and you want to crush it and you want to get a Dean Silver Medal or some kind of crap and some accolades and you want to get 100% on everything, then how do I know I did it correctly? Well, it said I should have the solution. So what was x? I don't remember anymore. 5. And y was 4. So that should work in simultaneously in both equations. So 2 times 5 minus 3 times 5. Is that right? No, times 4. Don't use the same number. Is what? 10 minus 12, which is -2. It worked, and it is the solution. You have an immediate feedback. And then what does this say? Last time I checked, this I can do by myself. This is 5 plus 4 is 9. Check. That one did it too. So it solved them simultaneously. So this is also what they're saying, but you're doomed to live lives forwards and understand it in reverse. So when Mark writes the book, he says a solution to a linear system is an ordered pair which will solve both equations simultaneously. And what we mean by simultaneously is it can't just solve this one and not this one. It has to solve both. But it did solve both. So that has to be the unique solution, which is now good for what I was talking about before in my rant. You don't want to change the numbers when I do the inverse matrix or Kramer's rule. I now know that this is the solution. So now when I give you bigger machinery on how to find the inverse of a matrix or all these determinants, and Kramer's rule says that this unique solution would be ratios of determinants, I know what the solution is, so then I can get a feedback. Don't switch to new numbers. Keep the numbers the same and focus on the process. This is how you do math correctly. I also need at least one of these because there's some kind of
geometric interpretation.
Oh yeah. Read the question. Also, there's a disembodied voice that's smarter than me in the background saying, read the question correctly. There's smart and stupid and there's intelligent. So solve this linear. So once, so when you do the equations on the exam, take a second, take a breather, and have that disembodied Lorenzo in your head say, "Hey, reread the question again and make sure you answered everything that they asked for." So, and it says, and then comment on the geometric interpretation. I also like the fact that it says comment on the particular or on the geometric interpretation. So if you wrote in your comments, I don't want to tell you what the geometric interpretation is, I have to give you marks now because it just said comment on it. Zing. So what happened there was, oh, now you're going to make me 3y equals -2 and then x plus y is 9. You don't have to draw it, but I guess I could do this calculus. This Yeah, this is y equals negative x plus 9. So if I sketch it, and Mark, why did Mark give such numbers? But if x is 0, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9er. And then when y is 0, x is also going to be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are unit lengths because I said, oh, I was listening to my daughter play double bass before this. So there's the first equation. Then the next equation is going to be 3y equals 2x plus 2. And so that means that y is going to be 2/3 x.
You're all good.
I know. I was just list. I want to be involved in your conversation too. So, but yes, this is the thing that I want to say. Also, I think that he's pointing out is that from the student's point of view, as soon as I do this, you're like I'm in linear algebra, and as soon as I do this, I'm in calculus. It's like they're the same equation. It's a different avatar for the geometric avatar of that guy, and then this one is going to be now 3 divided by 3 plus 2/3, and somehow that's going to work. Mark made it look nasty, but now I have the mx plus b form of this equation, and when x is 0, y is 2/3. Oh, really? So then we're going to have 2/3. And then when y is 0, x is going to be -1 if I'm doing this in my head. Bring him over, divide, -1.
For the next ones, I'll just plot it on Desmos and share the screen.
Okay, yeah.
So just for this one, you're showing explicitly.
I'm just showing that I don't need a calculator. It's wet in between your ears. You don't need Desmos. You don't need ChatGPT. But now, do you see what happened? Oh, did it line up? Not the scale. 1, 2, 3, 4. 1, 2, 3, 4, 5. Look! The solution is whatever it was, 5, 4, or was it 4, 5?
5, 4.
Yeah, there we go. I was asking myself, stop commenting. No. But do you see, even when it was crappy fractions in this, what that's saying is that was the unique solution. So the geometric interpretation is the intersection of those two lines. That would be the hardest one anyways. You're like, I'll do the other ones. The other ones will have no solution, or it's the same line, which is much easier to draw. I probably should have done one of those, but I didn't know which one it was going to be. So this is the geometric interpretation, the unique solution of a 2x2 linear system, and what we could possibly do to 3M Mark. Oh, it makes me feel good when I can 3M Mark's phrasing of this. What they're really asking now, because Mark does this, I would only note to 3M it because Mark, he was a genius and says, give me the geometric interpretation of this. Otherwise, I wouldn't have noticed either. I gotta stop drinking so much coffee. But what happens here is you're phrasing it as solving a linear system and finding the unique solution. But what they're really asking is, what points, can you see that?
Yeah.
What points in R2, points xy, what ordered pairs in xy are on both lines? If you phrase it that way, then it's easy. Also, what it's saying is, if you took, you could, so that's a geometric interpretation. If you want me to go back to algebra, and the pedagogical one that I always use is, for just for convenience, because it's in my head. Also, I have the same numbers in my mind, so I'm not creating new ones. And then Mark gave me new ones, and I'm like, I'm going to scrap those new numbers. I'm going to go back to my old numbers to rephrase what's going on. If I do this now, and if you're in my class or you've watched my YouTube videos, you know that very well that I use this system a lot, and I don't even change the 4 and the 3, which I could, but why? It doesn't really matter. What this says in plain English, in not geometric terms, but in algebraic terms now, is, can you find two real numbers that add to 4 and subtract to 3? So it's just a different way of viewing these types of things. But then you get catfished by saying, oh, we're in linear algebra, and I have this system of equations, but intuitively you're looking for either two numbers which add to 4 and subtract to 3, or geometrically it's not quite this one, but it looks similar to this one. You're looking for the unique solution to the intersection point of those two lines. Yeah, that's what's inside my head. Also, look at how long it took me to just do 1A to describe and talk about the solution. It had nothing to do with the numbers that was in that half-hour rant. It was about the technique and the process of what's going on to obtain the numbers, which is the unique solution 5-4. The answer is 5-4. It's like, that's the difference between a solution and the answer. The answer is 5-4. The solution is this. But now that I've done that rant, I can do the rest of it much quicker. What's the next one? 1b says negative 2x plus 3y equals 3, and 6x minus 9y equals 1. They're dividing by 3. I can already see it, but let's try. What we're going to do is immediately augment the matrix. Negative 2, 3 equals 3. 6, negative 9 equals 1. I don't, well, I don't want fractions. So the way that I want to do this is I want to eliminate this guy below now. I think that possibly either Mark is being mean to me now and there's fractions, or one of these rows is going to go away and there's infinitely many solutions, and so there is probably fractions, but I still want to work as hard as I can to get to REF without doing fractions. So I can see if I multiplied this row by 3, I could get 6 minus 6 is 0. So even though I didn't get a leading one, you do want to get a leading one, but the rules are made to be broken because it's not just about following stupid rules that people instantiate upon your life. It's trying to get the best way and the easiest way for you individually to find out what the correct answer is to a given problem. I'm couching this into I'm angry, but this is going to be row 2 goes to, so what I'm going to use is a Diophantine equation. I'm saying how many, which is ironically going to look like our linear systems, but how many of x's do I need and how many negative 2's do I need to get a 1 or to get a 0, which is a homogeneous Diophantine equation. And I see if I multiplied this by 1 and this by 3, I could get exactly this. So my move is going to be row 2 goes to row 2 plus 3 row 1. And that's going to give me negative 2, 3, 3. 6 minus 6 is 0. Negative 9 plus 9 is 0. Uh-oh. And then, oh no. Okay, it's the contradiction one. Yeah, we don't have to do it. This is 10.
So I'll put up the graph.
Is that correct?
Yeah, this one's a contradiction. No solution.
No solutions.
Yeah, here's the graph. Here's the geometric interpretation.
Mm-hmm. Good.
There it is right there.
Oh,
Parallel lines.
I can't see anymore. I want to see. Yeah. Oh, you're getting sophisticated and stuff. You're allowed to come over more.
Oh,
Oh, wait. Jasper the horse is here. Is he the only one? Yeah. Okay. Oh no, 6 viewers, 1 subscriber. And one, I can see why the subscribers go down when I haven't streamed for a while. But also, why is this now? Interpretate and go back to this unique solution. As I promised, negative 2x plus 3y equals 3 hasn't changed. The first equation didn't change. But now what does this say, and why is this the contradiction? For all intents and purposes, it's a 1 by 1 linear system, again. But what that says is 0x's plus 0y equals 10, which is bad because this is 0 plus 0, which is equal to 0. So that says if there's a solution to this equation, 0 has to equal 10. And one of the sides of the equation is missing a 1. So that can't be. So this is a contradiction. And now I need, what's the last equation? I'm also trying to predict, don't predict unique solution, infinitely many solutions, no solution. If that had gone away, if that number had been a 1/3 when I multiplied by this and it had gone away, then there would have been fractions in the solution. Did Mark do that for the first one? Let's do 1C and find out. It's all rhetorical. Don't steal the thunder. I want to find out on my own. I remember a bunch of students were saying, bringing me problems, and it was Laplace transforms. I'm like, oh, I get to do Laplace transforms today? They're like, you said you get to, like you're happy, not I have to do Laplace transforms. I'm like, yes, you are correct. You are correct. 8, 6y equals, I'm going to guess, 8 again. Yeah, it has to be. So this one now, I can see that this one is 2 times the first row, but let's see if you can see this. 4, negative 3, 4, 8, negative 6, 8. Oh, you guys are lucky because I left my pop upstairs. I don't have the DTs. This is 8. So what I'm going to do is I see if I did 8 times plus 4 times negative 2, that would give me a 0. And that's what I want to do, is eliminate below. So, and there will be fractions in this one. So this is going to be row 2. My goes to row 2 minus 2 row 1, which will give me a row of goose eggs, as Folkerunda likes to say. What's good for the goose is good for the gander. 8 minus 8 is 0. Negative 6 plus 6 is 0. 8 minus 8 is 0. So we got a row of zeros. So this is REF again. In this assessment, I can see I do have the staircase. If I have any 0 rows, they go above the non-zero rows. If you have a leading entry, you have to have zeros below. If you have any 2 non-zero rows, the leading entries in the upper row has to be further to the left than the leading entry in the lower row. But this is vacuously true because I don't have any other non-zero rows. I only have 1 to compare. But if I want the solution for this, I'm probably going to write this as row 1 goes to 1/4 row 1, which will give me 1 negative 3 over 4. 1 0 0 0. This is also an REF. REF is unique up to the leading entry being a 1, is what they'll say. What did that turn into? That turned into x minus 3 over 4y equals 1. And this is where slightly the linear algebra does change. Kicking over the guitar again. This is where it slightly does change. Can I be? They need more performative males. So you want me to be a performative male after this? Wrong. So I know. We were talking about I just watched I didn't know what a performative male was till the internet told me. Tim tried to talk about it a while ago. And I was like, I don't understand what you guys are talking about.
I think there may have been some preamble in your head there that we all missed out. I have no idea what the hell just
What a performative. I was like, I'm going to play the guitar and pretend like I'm cool.
Oh, okay.
Performative male. So basic.
You do realize that what you're talking about is the John Cougar Mellencamp song is forget all that macho crap and learn how to play guitar.
Yes.
Cool. You gonna break that thing or should I take it over here so we don't have to see?
Yeah, there you go. Performative. So, what was I doing?
I'll put on the geometric interpretation now.
Oh, so in the last one, there was no solution. So, what that meant was, so for B, I forgot because I keep forgetting to read the question. But what that said was they were, for all intents, which way did it go for B? B would have been, the slope is positive, right? So, they both would have been going this way. So I didn't draw them to scale, but they're parallel lines. So when I'm asking in part B, not this one, but in part B, I'm asking which points in the plane are on both of those lines, and there can't because never the twain shall meet. These ones seem like they're going to meet somewhere in the future. In the past.
Each other at the end of time.
Well, okay, those are parallel lines. The parallel lines. Don't hold your breath for that, or a full-time job. Don't hold your breath. You might pass out. So in this one now, what that says is because we got the row of zeros, Lorenzo's going to load up the geometric interpretation. But if you want, I could do it here also. That original equation is just the first equation multiplied by 2. You can start seeing it, but it was the same line. So every point on that line, I want to point at the screen now. Every point on that line, if they're the same line, then yes. Is it that way or is it the other way? I also did that backwards in the other one. That means positive slope. So it means they were the same line. So every point on those two equations, or on that line, satisfies both of the equations. It was the same equation. In the last one, let me do it correctly. This is positive slope. But if they're parallel, what uniquely defines two parallel lines, especially in mx plus b form? Their y-intercepts. Their slope is the same because they're slanted slightly this way. What? So it's not the slope anymore that determines them. Your parallel lines are uniquely determined in the Cartesian plane by their y-intercepts. All right. That was number one.
You're gonna hate me.
Yeah.
You know what?
What?
You're gonna hate me for number two. The four by
I know. I was like, we're gonna probably do a couple of these, and then we might have to start doing it. And I'll also put a PDF later tonight because I'm never gonna get there all the way, and we've lost the viewers because all they wanted to see was this. But yeah, these ones. Yeah, these ones. Now I just have to write them out.
You can just dump them straight into matrix form.
Okay. I'm not going to try and do that back and forth. 2a is x1 plus x2 minus 2x3 plus x4 equals 8. I've never solved this system before. This is what's funny. Students are like, yeah, slow your roll because I've never seen it. I've never seen it. In theory, I know how to solve it, but I've never seen what you're talking about. 3
Able to solve infinitely many.
negative 1. Yes, if I had enough time. I could paint Gabriel's horn, but never fill it with volume or fill it with paint. X4, that's a calculus problem.
Yeah, that messes me up. That Gabriel's home.
What's the paradox? You'll never have enough infinite amount of time to do either, so it's okay. Gabriel's horn is 1 over x from 1 to infinity rotated about the x-axis, which will give you this. And then they're like, well, it's infinite, so they use it up to the angel Gabriel. And what happens is the surface area is less than infinity, but the volume is infinity. So how could you paint the outside of it and never fill it with paint? I don't know. You don't have enough time to do it either way. We're finite, discrete creatures. Oh, this board is also, I shouldn't, how far? Can you see this?
Yep, that's all good. You can go right ahead.
So I'm going to augment the matrix. 1, 1, negative 2, 1, 8. Oh, that made a noise, a sound noise I liked. A sound noise? I don't know. 3, negative 1, 1, negative 1. I hear Jasper chatting. I see Jasper chatting. I haven't read anything yet.
So he just asked a question that I said, I noted the question for later, but I just said we're doing the assignment solution.
At least you're here to support me. At least 1 or 3 people care. I can count to 3 at least. There's 2 of them here. I gotta stop luring people to the basement, but if you want to come over, Jasper.
Waiting for the candy though.
Yeah.
Where's the candy?
Where's the candy? It's over there. Just bend down over there. You'll see it. You'll see it. It's Twitch. So now we have a leading 1, which Mark gave me, which is nice. Or Lorenzo. I don't know who changed the numbers slightly. But what we have to do is eliminate below. So, and also a good way to do this is 1, 1, negative 2, 1, no, 1, 8 isn't going to change. But I can do the 3 row operations all at once. So the row 2 is going to go to row 2 minus 3 row 1. This is a negative 1. Row 3 is just going to go to row 3 plus row 1. And row 4 is going to be row 4 minus 2 row 1. So I'm going to do 3 row operations so I don't have to write the matrix out over and over and over again. So if you were doing the homework and this really bothered you, then what we can do is get the 3 zeros here all in one. New matrix. So from here, I am still doing that. I'm going to multiply this row by the first one we're doing is negative 3. I'm going to multiply it by, so 3 minus 3 is 0. That's why I did it. Negative 2 minus 3 is negative 5. 0 plus 6 is 6. Negative 1 minus 3 is negative 4. And what? You're going to make me do 8 times 3? What is that? 16, 24, negative 24 plus negative 21. When I say it out loud, I'm just still asking myself. When I talk to myself, I prefer to be alone. The next, yeah, I see why I hate you already.
I have the solution or the answer here if you.
You've got the answer. I don't want to see nothing. Now what we're going to do is multiply by negative or positive 1. So we're just going to add the two rows. So 1. You just let me know. Well, you don't have the solution. So if I make a mistake along the way. Also, you'll see that I will make mistakes. Mistakes are made. This is not what I'm looking for on the exam, is perfection necessarily, just that you know the overall rough process. Get it right. This will be 0. 1 plus 1 is 2. Negative 1 plus negative 3, or negative 2 is 3. 1 plus 1 is 2. And then that seems like a similar pattern. Oh, we'll see. We'll see. 2 is 10. Now we're going to multiply by negative 2 in this row. And 2 minus 2 is 0. Negative 1 minus 2 is negative 3. 1 plus 4 is 5. Negative 2 minus 2 is negative 4. Okay, yeah, they're just chaos. And then negative 16, 17, 18, 19, negative 19, if I did that correctly. And then now here's where you'll see I have up to the negative 3 prime numbers. Negative 3 and negative 5 aren't prime numbers. Why? They have to be larger than 1. They're the negative of a prime. Nobody really thinks about this, but prime numbers are positive numbers. Well, so now what's next? I now know that for all intents and purposes also, you can ignore that. That guy's done. But now, since we have you here, this is a 3 by 3 linear system. So now I forget the fact that I was in a 4 by 4 linear system. And I look at this one and I say, what's the mantra? This is how I know once I have zeros below it. This is why I know I can essentially ignore the first row and the first column. Also, when we're finding the determinant of that coefficient matrix, I only have to compute one sub 3 by 3 determinant for later assignments because I'm going to cofactor span along this column. So I can ignore the column and the row and now I have a 3 by 3 linear system. If I divide by negative 5, I'm going to get fractions. If I divide by 2, I'll get fractions. Only 1, but it's still horrible. And then if I divide by negative 3, I'll get fractions in all of those. I don't want to do that, but I see these two numbers can conspire to give me a 1, a negative 1. So now you'll see that I want to use Diophantine equations. What I'm asking is what groups of 2 minus what groups of 3 would give me a 1. This will work if and only if the GCD of 2, and for all intents and purposes, the other number is 1. You can ignore the negative. We can absorb it into the y. And that's true. 2 and 3 are both prime, so they have to be relatively prime. Therefore, their greatest common divisor is 1. So there will be a way of doing this. This first non-trivial solution to this is 1, negative 1, 1. No, negative 1, negative 1. Oh. So what we're going to do is, long story short, don't mix subjects together. Yes, you should. This is what Henri Dieudonné and Lebec and these guys in the Nicholas Bourbaki Club are saying. Math is a twisted ball of yarn. It's our job to show you where these things connect to each other. Calculus and linear algebra not only mix, but linear algebra is the tool I use to do multivariable calculus if you're doing this correctly. I'll digress eventually.
I'm gonna make you do that history of math.
Thing again, yeah. Once we get on there, I need to get my mind right. It's really hard to be happy and enjoy things when you can't get a full-time job and pay your bills. It's really disconcerting. So row 4 is going to go to row 4 plus row 3 is what we're going to do. I'm going to squeeze it. Oh, there's an entendre there. I'm going to squeeze it in right here. I'll shut up. Negative 2, 1, 8. But asking my 17-year-old daughters about swearing is that they just laughed at me. You've never heard swears before, have you? Yes, they have. Beta. So what I'm doing is changing. So also notice on an exam, the two things the engineers always like to ask themselves or forget to ask themselves is they only ask one thing ever, always. Do I know how to do the problem? Yeah, I know how to build a bridge. Look at my pinky ring. It's And it's like, okay, C's get degrees. Yeah, but not jobs after. How long does it take you to build a bridge? Well, I don't know. So if you don't know how long it takes you to do a task, I'm probably not going to get you to do the task. I'm going to ask the guy that knows, or the girl that knows how to do it and knows how long it takes them to do it. So on an exam coming up this Friday, which I haven't made the exam or sent them to ADR yet, and I'm getting extreme time sensitive emails. So when you get those there's one. When you do this, you have to ask yourself, how long does it take you? How long does it take me to redo a problem? A long time, because I talk a lot. But when I'm not talking and I'm doing it for myself, what I did was I quickly wrote down the other 3 rows I'm not changing. Now I turn on my thinky brain. Thinky brain, I'm going to add, luckily. So we're just going to add. -3 plus 2 is -1. 5 plus -3 is 2. -4 plus 2 is -2. And okay, good. -19 plus 10 is -9. The numbers went down. I also am lazy, so I'm now going to do row 4 goes to, after I do that, row 4 goes to negative row 4, which will give me plus, minus, plus, plus. Good. Now I have a leading 1. Now what I'm going to do is interchange rows 2 and row 4, which is going to give me what? A headache among other things, but a matrix closer to the solution. Thank you, Carl Friedrich Gauss. You try to come up with this meme and figure out how to do row reduction. But now we're in business. I have 1, -2, 2, 9. I said these 2 rows, so then we're gonna do 2, -3, 2, 10, and then this row goes there. -5, 6, -4, -21. Now we should be in business. I have 2 leading 1s. I hate you, Lorenzo. And then now I have to get. It's like, what? That was our. We didn't get the preamble for what your brain was thinking there. Also, he said I would eventually start hating them. I see why the students were complaining so much. Pain is weakness leaving your body. Wait, what's that? No, dude, talk. Stand by. No one's to leave the ship. We're not done yet. You can't ditch me yet. All right, that was Kirk. Now I have a leading 1. I can eliminate below. So now what we're doing is we're eliminating y, or x2. We had x1, x2, x3, x4. I eliminated x1 from these ones. Now I have a leading 1, and I can eliminate x2 from these 2 equations. Then if I get there, we'll have eliminated x3 also. So I've eliminated everybody, but a 1-by-1 linear system is the idea. It doesn't matter how big the system is. Ironically, if you do this correctly, like Gauss and Mark and me, I tried to put myself into a better category by associating myself with Gauss and Mark Solomonovich. I think those 2 first are in the category. I'm not sure if I'm there. But what we're trying to do is, ironically, just solve linear 1-by-1 systems. We're not trying to make this difficult. We're trying to make it easy. So I'm reducing this 4-by-4 horrible system to a 1-by-1 linear system at the end is what's happening. Let's do that. We're going to have to start erasing. Row 3 is going to go to row 3 minus 2, row 1. And row 4 is going to go to row 4 plus 5, row 1. Let's put that here. Mistakes have been made. 1, 0, 0, 0. So we're doing 1, -2, 1, 8. I don't have to change this row anymore. We're done with that one. We'll almost be done with it completely. -2, 2, 9. Then now what I'm doing is I'm multiplying this row by -2. So 2 minus 2 is 0. That's why we did it. Notice that I say this over and over again as a mantra, that I can't really get it wrong. Oh, is that happy? Did he give me a win? Yes. -3 plus 4 is 1. Oh, I'm happy with that. I don't hate you anymore. 2 minus 4 is -2. 10 minus 18 is -8. Switch to, now we're going to multiply by 5. -5 plus 5 is 0. That's why we did it. 6 minus 10 is -4. Okay, good. And then it doesn't get huge. -4 plus 10 is 6. What? 45 minus 21. Line it up. Write out what you're doing. 5 minus 4 is, or 5 minus 1 is 4. 24. I cannot do that in my head. Do you see? Don't be afraid. I have a PhD. 24. Oh, fractions. There's fractions. Okay. Now do you see? Now we're at the stage where I can eliminate this, and I can eliminate this, and we're at a 2 by 2 linear system. 2 by 2 linear system. What that 2 by 2 linear system looks like was, okay, it says x3 minus 2x4 equals negative 8, and negative 4x3 plus 6x4 equals 24. So I have a 2 by 2 linear system. What Gauss is doing is reducing it to a 2 by 2 linear system, but I don't want to be done. And should I start solving yet? I probably could, and I could redo that. But the mantra is, if you're not in REF, don't tell me what kind of solution you have. You can't tell yet. So we got one more move to do, and then we'll be in REF. It looks like we're going to have a unique solution. But I'm not going to guess, and I'm not going to start deciding until I get to REF.
Trust your intuition, my young Padawan.
Yes, and stick to your guns. We now have 3 leading ones. I have one more row to give, and in that step, Mark actually finally, or Lorenzo, whichever wizard it was that did this to me, now I can only do one more move, and we'll be in REF. So I'm going to do row 4 goes to row 4 plus 4 row 1. Which will give me, I'll leave this so we can do backtracking. Now you see why, unless you're finding the inverse of the matrix, and if you wanted to ignore this, find the inverse of this 4x4 matrix, that's a lot of row operations, and you don't want to do that. That's why I train you to do cofactor expansion and determinants. Also, the moral of the story should be, this is how long it takes me. I'm ranting and talking, and we're having fun as we're doing, for lack of a better phrase, fun. Fun math is not an oxymoron. But as we're doing this, how long did it take me? This is not high school anymore. You can't do the homework the night before. Well, I could, but I'm a wizard. But in general, this won't work out the way that you thought it was going to. I took Math 33 and 23 in high school because I was a delinquent and had no parental supervision from 14 on. So I did whatever the hell I wanted. But I had enough wherewithal that I should probably get my graduate so I don't have to do a GED or anything later. So I took 23 and 33, which is the equivalent of having to do nothing or the dumb math class. But then I could just walk in and be like, we have a test today, 80%. See ya. And then go outside again, be a delinquent. Seems like now my life isn't sorted out. Don't be a delinquent when you're younger. It might cascade into being a nightmare when you have a 17-year-old of your own. She's a good kid. I was not. This is me breaking good, not breaking bad, people. So what are we doing? We're multiplying by 4. Negative 4 minus 4 is 0. That's why we did it. Negative 2. 6 plus negative 8 is negative 2. Come on, give me a win. Really? 24, 32 minus 2. Notice that I'm doing it upside down. Oh, I got to borrow. Why do you got to borrow? 12 is 8 last time I checked, so that should be a negative 8. Don't worry. We're sharing sheep. You do it however you want. That's how my brain had to do it. This is REF, but I'm going to divide by 2 to give me 1 and 4. That's not so bad. So what does this say? Am I in REF? Yes. I have no rows of zeros. I have leading ones and I have zeros below them, which is going to give me an upper triangular matrix. Why do they call it upper triangular? Everyone wants to focus on the zeros, but the upper triangle has the information in the system now. So they call it upper triangular in the coefficient matrix. But in that upper triangle, now we have to backtrack, or you can have to kill these. How many more row operations do we have to do to get to our REF? 1, 2, 3, 4, 5, 6. Back. So we're done. Once I'm here, this literally is a 1 by 1 linear system. That says x4 equals 4. Is that the correct number?
Yeah.
It's like I've done this before. Now this says x3 minus 2x4 equals negative 8, but I know that this is a 4. 0? Oh, yeah. This gives me a 4, so that says x3 is 0. Yep. I like this. That means that can go away and that can go away. Do you see immediately? It's 0. But we'll keep going. Then the next equation, in this equation, this says x2 plus 0x3 plus 2 times 4 is equal to 9. 1. So x2 is 1. And then in the last equation, let's do it right here. This says x1 plus x2 plus 0 plus x4 equals 8. This is a 1. This is a 4. I can do that in my head. 3. So x1 is 3, x2 is 1, x3 is 0, and x4 is 4 is the unique solution to this linear 4x4 system. What that says is there is a unique intersection of all 4 of those lines in 4 space, which all are at the coordinate 3, 1, 0, 4. That's the ordered quadruple.
So I don't have that much more time. Do you want to continue this?
I'm supposed to do office hours because I haven't been attending my office hours in McEwen, and I signed a contract, so they're mad at me. So I have to switch and go on to Zoom.
Okay, well, we'll post these ones. Do you want to just say that we'll post these ones and then we'll do the rest next weekend?
What that disembodied voice said in my head, I'm hoping there's people behind that curtain over there. Otherwise, it's the Wizard of Oz, and I've gone completely crazy. But what the disembodied voice just said, if you can't hear it, is I will post this, and I will post the solutions, a PDF to this, in the link on the YouTube video and on Meskiness for McEwen. I'll have a good day. I'll see you next time. If you just showed up, we'll do streams longer, but we'll have to weed out when I'm going to do this because I'm supposed to do office hours now. And I usually also tutor Isha. Don't say their names. I didn't say her last name, but she canceled today, and that was earlier today. So I really wanted to do, we're doing 315, which is the differential forms and stuff like this, and then ordinary differential equations.
Nice. All right. Goodbye, everybody.